Hello guys, we will be discussing the application of linear algebra in Football League.
Hello, my name is Muhammad Hidib bin Sharuniza. My matrix number is 20224 72406 and I'm from group JCDCS 1434E.
My name is Akram Afif bin Azhar with matrix number 2022 873
Hello, my name is Muhammad Ani Hazri bin Johari with matrix number 2022 856 924.
My name is Anur Najila binti Karul Nizam from JCDCS 1434E with matrix number 2022 625 484.
My name is Nur Aina Fariha binti Mafazid and my student ID is 2022451616.
So, for the introduction and purpose of study, linear algebra is the study of linear relationships between variables like lines and planes in space. It's essential in various fields like maths, physics, engineering, and sport, helping solve real-world problems by manipulating equations and understanding geometric shapes. Our purpose of study is to calculate the point that the football teams will get if they win, draw, and lose the match. By using matrix, also it can make the calculation for each team points easier.
So, as we can see, this is the Malaysia Super League, or we can say MSL, for season 2023. And on the table, these are the top 3 standings.
For the problem statement, as we can see here, we have 4 problem statements. The first one is, based on the table, simplify it to augmented matrix form if goal for GF, goal against GA, and goal difference GD is ignored. Second, find the determinant of the matrix and determine whether it is a singular matrix or not. The third one is, find the point for each win, lose, and draw by using the inverse method. And last but not least was, the organizer changes the format and changes the point allocated for each win, draw, and lose. Find the new value of win, draw, and lose using the Gaussian elimination method based on the matrix given below.
Now, for the first problem, based on the table, simplify it to the augmented matrix form if goal for GF, goal against GA, and goal difference GD are ignored. Now, for the solution, we are going to take the win, draw, and loss column and then turn them into a matrix, which is a 3 times 3 matrix. Now, for the matrix B, we are going to use the PTS column. As we can see, it will going to form a 3 times 1 matrix. Now, to get the matrix C, we will get the 3 times 1 matrix, and it will gonna be a win, draw, and lose for each row.
The second problem is find the determinant of the matrix and determine whether it is a singular matrix or not. By using Sauer's rule, firstly, we need to rewrite the first 2 columns at the right hand side of the matrix. The formula of determinant is S1 minus S2. To find S1, we need to multiply all the diagonals from top left to the bottom right and add them together. For S2, we need to multiply all the diagonals from bottom left to the top right and add them together. So, S1 is equal to 235 and S2 is equal to 495. Using the formula, the determinant of 8 is equal to negative 260. Since the determinant is not equal to 0, therefore the matrix is not a singular matrix.
Let's go to the third problem. Find the point for each win, loss, and draw by using the inverse method. So, firstly, we have the matrix A, B, and C. Then, to find the total point, number of win multiplied with W plus number of draw multiplied with D plus number of lose multiplied with L. By using the inverse method, we will get C is equals to A inverse times B. Then, we need to find A inverse using inverse method since matrix A have 3 by 3 dimension. So, we need identity matrix which is 3 by 3. And then we apply ERO until we get R square EM. Firstly, we will apply the first ERO, which is 1 over 25 multiplied with row 1 to replace the row 1. So we will get the new matrix, which is the first entry for the first row is 1. We need to multiply negative 20 with the first row and plus it with row second to replace the second row. And then negative 17 multiplied with row 1 plus row 3, replace it with row 3. So we will have the new matrix, which is all the entry below 1 is 0, but for the first column only. Now we multiply the second row with 5 to replace the second row, and then we will get second entry for the second row is 1. Next, we will multiply negative 1 over 25 with row 2 plus with row 1 to replace row 1, and then negative 58 over 25 multiply with row 2 plus row 3 to replace row 3. So what we need to do is we will multiply negative 1 over 52 with row 3 and replace it to the new row 3, so that we will have the third entry for the third row is 1, and then we apply another ERO, which is negative 25 multiplied with row 3 plus row 2 replace with row 2, and row 3 plus row 1 to replace row 1. Now we have a new matrix, which is the last matrix that achieve R square EM, and for the right side is the A inverse matrix. Now back to the equation of the inverse method, which is C is equals to A inverse times B. So we multiply A inverse with B and we will get the matrix C, which is 3, 1 and 0. Therefore, each win will get 3 points and each draw will get 1 point, and the team won't get any point if they lose the match.
Lastly, the fourth problem is the organizer changed the format and changed the point allocated for each win, draw and lose. Find the new value of W, D and L using Gaussian elimination method based on the matrix given. As stated in the question, we need to use Gaussian elimination method. Since we only use REM, we just need to solve it until all the entry below leading one is 0. To find leading one in the first row, we need to do 1 over 20 multiply with row 1 to get for the row 1 is 1 over 4, 0 and 2. Next, we reduce null 0 constant for the second and third row under the leading one on the first row. By doing negative 20 R1 plus R2 and replace it to R2, we will get 0, negative 4, 4, negative 8 for the second row, and for the third row, by doing negative 15 R1 plus R3 replace to R3, and we will get 0, negative 3 over 4, 7 and negative 14. After get all 0 value under the leading one in first row, the same step we need to do on the second row to find the leading on the third row. Then we reduce the null 0 constant under the leading one on the second row. Lastly, for the row 3, it also doesn't have leading 1. To get leading 1 in row 3, 4 over 25 multiply with R3 to get 0, 0, 1 and negative 2 on the row 3. For the last step, we need to transform it into system of linear equation and substitute it into until get the value for L, D and W.
In conclusion, we can conclude that linear algebra can be applied to many real-life problems and can be used in our daily life. Linear algebra also can be one of the other alternatives for solving simultaneous equations. Therefore, we should learn to use this knowledge so that it will be useful for us in the future. Here are some references to make this video. That's all from us. Thank you.